into some basics here today. Okay, let's come back to the program here. Let me turn off the server for a minute. So let's look at the program here. The program that we used, the most important codes, one of the most important type of code is called a G code. It's a preparatory function for the CNC machine. So the preparatory function, those function is used to drive the axis of the machine, like the x-axis, y-axis, z-axis, make the move according to the user's the need. So the some of them, most basic motion is from G1 to G3. Okay. G1 and G2, these two very similar. The only difference is G0, oh sorry, not G1, G2, G0 and G1 is a group. They all using a linear move, or it's go straight line. And the G2, G3 is a command to make the axis move along a arc or circular motion. Okay. So our circular motion needs the coordination of two axes, minimum of two axes. And the linear motion may not need both axes, but sometimes you also need both axes. For instance, if you're trying to move along a diagonal, then x and y has to be moving at the same time. But if you just move along x-axis, then y doesn't need to move. You just drive x-axis or the y-axis. So linear motion also can involve both axes. And the other two is G90 and G91. They are two different kind of programming mode. So G90 is absolute programming and G91 is increment programming. Absolute programming, what it means is you only have at any given moment for the whole process of programming, you only use a fixed origin. So like just like what we did, this is my origin 0, 0, 0. And for increment programming, this 0, 0, 0 is moving with the tool. So it's not fixed. So if you say, I want to use the increment motion programming mode, then suppose that basically means anywhere the tool is currently located, that location is 0. Then if you specify, I want to move to x1, that's measured direct from where the tool is right now. So x1 means go 1 unit to the right of the current position. So absolute motion is not like that. If you are right now sitting at 2, and you're trying to move 1 unit to the right, you should specify x3 instead of x1, because the 1 unit to the right of current position is x3, not x1, right? So that's the only difference of these two. And you will see the application of both mode in this program. And I suggest you to stick with absolute, because increment can get confusing and you easily lose track of where you are. So if you have to like trying to figure out, if you use increments, then you actually lose the sight of the whole picture. You don't know in the it's like just like the GPS, you lost the global coordinates. You don't know where you are. But using absolute, you will always know with respect to the fixed 0 where you are. You can easily find the other spot. And but some occasion, the increment mode is very convenient. So we will see an application of that in the code. So let's look at it line by line. First line, M10. So the encode is optional. So encode is help you to kind of organize your program better. And also it makes it easier if you are working as a group. For instance, two of you actually discuss the code. you can refer to the line and say, let's talk about the line N65, then everyone is on the same page. Otherwise, it's hard to locate the line of the code. But this one is actually optional. You don't have to have it, but it's nice to have if you want to have the program very well organized. And your assignment, I strongly recommend you to use the N code in your program. And also, if you probably noticed that the number behind the N is not consecutive. You actually have some space in between, like N 10, 15, 20. The main reason behind that is that you can actually easily make changes. You can insert more lines in between in case you made a mistake, you want trying to fix that, then you have flexibility to add more lines in between. Okay, so each line, at least the first line, they start with the G code, start with G0. G0 is rapid motion. So it's called rapid position, rapid traverse. So rapid traverse means it's usually used when the tool is moving in the air. So it's not really cutting anything. So that was designed for the tool moving from point A to point B with the fastest speed. So in industry application, you want to minimize or reduce the amount of time that are not really in cutting, right? You want to maximize the productivity, then you want this kind of travel to be fast. So G0 is usually for the tool to move in the air from point A to point B. So that's exactly the case for our program. And the second, followed by G0, we have a G90. G90 is specified by using absolute programming mode. So everything that we specified is measured from the fixed origin. And then followed by the X, Y, Z coordinates. So we are going to go to X0, Y0, Z0 means this, after execute this line, the tool is go from wherever the tool is currently located. It's going to go along a straight line from here all the way to the origin of whatever you set it up. So it will go here. So it will move all three axes simultaneously. So it's not going to go X first, Y second, then Z the last. It's not how it works. It always goes simultaneously. So if you're trying to trace the trajectory of the tool tip, it's going to be exactly, if you put a rubber band between this point and this point, that's the trace of the tool. And if you, for some reason, you don't like it to move like that, you want it to move first like in the XY plane, in this plane, from here to here, then drop down to Z. How you achieve that? The Z, you shouldn't move the Z. So you have to leave the Z unchanged. So whatever the Z is currently is, you should leave it unchanged. So the Z, you shouldn't specify that. So if you leave it out, like if you don't specify the Z, then the Z will stay where they are. They don't move. And that's we call the modal. So a lot of program mode like G0, G1, G90, and also the XYZ, if you don't change it, it will stay the same. So let's look at the second line. Second line, you can see now we change to G1 mode. G1 is also a linear motion, but compared to G0, the difference is G1, the user has to specify how fast you want to move along the line. So the speed is user defined. So it can be faster than the rapid move, as long as you don't exceed the machine specification. But most of cases, you actually move slower. Usually that was used in the real machining operation. The tool is inside the workpiece. It's doing the cutting. So you want to slow down the process. So make sure the tool is not break or you don't damage anything. So G1, then you also follow by a coordinate x, y, z. And in this second line, we didn't specify x at all. The x is not specified. That means x stayed the same. From previous line, we know the x already in position of 0, so it's equivalent. If you want to write everything out, you can also say G1 x0 y2 z0. So that's equivalent to what you see here. The F code is specified speed. F40 means running at 40 inch per minute. That's the speed. Okay.